everyone, I'm Sarah May A. Sarga from Block 2. So for today's video, I will discuss to you the mathematics in our world, the mathematical language and symbols, and problem solving and reasoning. So Unit 1, Mathematics in our world, pattern in natures and the regularities in the world. So the patterns in natures are visible regularities of forms found in the natural world. So this pattern occur in the different contexts and can be sometimes be modeled mathematically. So the natural patterns include symmetries, trees, spirals, meanders, waves, foams, desolation, cracks, and stripes. So classify the object according to symmetry. So the objects are said to be symmetrical if their pre-image and image have the same size and shape but are either mirror image or each of other has been rotated to go in a different direction from the first. There are three basic types of symmetry. This is reflection symmetry, rotational symmetry, and point symmetry. So, the importance of mathematicals in one's life. So, the mathematical help us to understand the world and provide us an effective way of building mental discipline. So, math also encourage logical reasoning and critical thinking, creative thinking, abstract or spatial thinking, problem solving ability, and even effective communication skills. So, mathematics makes our life orderly and prevent chaos sometimes. So, the Fibonacci numbers and golden ratio in the occurrence in nature. So, the golden ratio is best approximated by the famous Fibonacci numbers. Fibonacci numbers are never-ending sequence starting with 0 and 1 and continuing with the previous two numbers. The next number in the Fibonacci sequence for instance are 1, 2, 3, and 5. In fact, the higher the Fibonacci numbers, the closer their relationship is to 1.618. The golden ratio is sometimes called divine proportion because of its frequency in the natural world. So the example of this is the seed of sunflower, pine cones, twist and opposite spiral of Fibonacci numbers. Unit 2, Mathematical Language and Symbols. So I will discuss the language, symbols, and convention of mathematics. Mathematics is written in a symbolic language that designed to express mathematical thoughts. This article describes how mathematical thoughts, methods, and facts are expressed in symbolism. So that is emphasize how to read and write mathematics. So the characteristic of language of mathematics to make it easy to express the kind of thoughts that mathematicians like to express. So it is precise, able to make very fine distinction, concise, able to say things briefly, and powerful, able to express complex thoughts with relative ease. So the next one is, I will explain the nature of mathematics as a language. So mathematics is the same all over the world. Math can act as a universal language. So a phrase or formula has the same meaning regardless of another language that accompanies it. In this way, math helps people learn and communicate even if other communication barriers exist. And perform the operation in mathematical expression correctly. So, about mathematical expression, when we combine numbers, variables in a valid way using operations such as addition, subtraction, multiplication, division, exponentation, and other operation and function as yet unlearned, the resulting combination of mathematical symbols is called mathematical expression. So, we write an expression by using numbers, variables. So, we proceed on Unit 3, Problem Solving and Reasoning. So, I will discuss to solve to solve a problem. So there are 5 steps to problem solving. So the first one is to define the problem, gather information, generate possible solution, evaluate ideas, and choose one to evaluate. To solve a problem using inductive and deductive reasoning. So inductive reasoning is characterized by drawing a general conclusion, making a conjecture from repeated observation of the specific example. So the conjecture may or may not be true. So the deductive reasoning is characterized by applying general principles of a specific example. So there are examples of inductive reasoning. So examples of inductive logic is the coin I pulled from the bag is penny. The coin is penny. A third coin from the bag is penny. Therefore, all the coins in the bag are pennies. So there is an example also in deductive reasoning. So all men are mortal. Harold is a man. Therefore, Harold is mortal. For deductive reasoning to be sound, the hypothesis must be correct. It is assumed that the premises all men are mortal and Harold is a man. So, are true. Therefore, the conclusion is illogical and true. In deductive reasoning, if something is true of a class of things in a general, it is also true for all members of the class. Solve a problem using Folia's strategy. For example, a math class has 30 students, approximately 70% pass their last math test. How many students pass the last math test? The step 1 is to understand the problem. Make sure that you read the question carefully several times. We are looking for how many students pass the last math test. We will let it. So the number of students. So the next step is devise a plan. So it will be translate. So a number that is 70% of 30. A number is equals to 70 times 30. And step 3 is carry out the plan. So we are going to solve the problem. So x is equals, a number is equals to 70 times 30. And a number is equals to 21. So we are going to now is to multiply. And the next is step 4 is look back and check and interpret. So 21 is 70% of 30. So the final answer is 21 students passed the last math